Today we're going to talk about finding a quadratic from its graph. So depending on what information you are given, you can find the equation of a quadratic function. So let's talk about the first scenario. This is when you are writing the equation of a graph if you have its x-intercepts and its y-intercepts. So the first step will be you will need to write the equation in factored form, and you will need to make sure that you understand that the factors come from the x-intercepts. Okay, once you write your equation in factored form, you will then substitute your y-intercept into the equation, and then you can find out what a is. Once you do that, you will move on to the final step, which is to write out the equation in step one, and you include the value of a. So let's look at example one. So as you can see here, we have two x-intercepts. We have -4, and we have a +2. Okay, so those x-intercepts are x is equal to -4 and x is equal to a +2. So we should know that those come from the factors of x plus 4 and x minus 2, because remember we have to set those equal to 0. And I'm going to put here that this is going to be y equals the value of a times those factors. So now what I'm going to do is I'm now going to take the y-intercept, which is located at the point 0, -6, and I'm going to substitute that in as my x and my y value for the given point. So I'm going to have -6 is equal to a times 0 plus 4 times 0 minus 2. Okay, and then I can simplify, so that will be -6 is equal to 0 plus 4 is 4, 0 minus 2 is -2, 4 times -2 is -8 times a, and then I can divide both sides by -8, which will give me a +6/8 is equal to a, and if I want to, I can reduce that 6/8 to 3/4. So the value of a is 3/4. So now that I have that, I can write my full equation. It is going to be y is equal to 3/4 times a times the factor of x plus 4 times x minus 2. Now, if you wanted to multiply this out and take it from factor form to standard form, that is also fine. You have to multiply everything and then combine like terms. All right, let's look at example number 2. So as we can see here, for example number 2, we have one x-intercept, but we know because it's quadratic that that x-intercept is going to basically be a double root, or is going to repeat. So if we have x is equal to -1, then in factor form, that means we'll have y is equal to the value of a times x plus 1 times x plus 1. Okay, so once again, we will look for our y-intercept. This y-intercept is at 0, -4. So when we substitute this in, this is going to become -4 equals a times 0 plus 1 times another 0 plus 1. All right. So now that we have that, we can simplify. So that's going to be -4 is equal to 0 plus 1 is 1. We know 1 times 1 times a is just 1a, meaning that a is equal to -4. And when we write our equation, this is going to be y is equal to -4 times x plus 1 times x plus 1. Or, to be honest, we could write this as y is equal to -4 times x plus 1 squared, since the x plus 1 is written twice. All right? So it can be either or. Okay, either or will be fine. All right. So now let's take a look at scenario number 2. So scenario 2 says we are going to write the equation of a graph when given a graph, and we have its axis of symmetry, and we have an x-intercept and a y-intercept. So when you are given one x-intercept and the y-intercept and the axis of symmetry, you can use the x-intercept that you are given and the axis of symmetry. You can use it to find the other x-intercept. One thing that we need to remember is that anytime we have a graph and we have a axis of symmetry, the points are equidistant from each other, or equidistant from the axis of symmetry. So I know that if this is 2 units away, this is going to be 2 units away. So I'm going to take that same thought process when trying to write this equation. So the first thing that we do is we find the other x-intercept by using the axis of symmetry. Once we do that, then we can do what we did in scenario 1. We just continue from there, because we'll be able to write it in factored form, substitute in a y-intercept, and then find the value of a. So let's look here. So if we look at this example, we see that we have an x-intercept at -7. And we have an axis of symmetry at -3. So I know that from 7, from 7 to -3, that is a difference or a distance of 4 units. So I know I need to have a distance of 4 units from going from the axis of symmetry to the other x-intercept. So I know that -3 plus 4 is going to be a positive 1. So from that, I know that this other x-intercept here is going to be a positive 1 here. So what I'm going to do here is I'm going to write my equation in factor form. So that means that I'm going to have y is equal to a times x plus 7 times x minus 1. All right. So now I'm going to substitute in my y-intercept. The y-intercept is at 0, -21. So I'm going to substitute that in. So that is going to be -21 equals a times 0 plus 7 times 0 minus 1. All right. And when we simplify, we will end up getting -21 is equal to -7 times a, which means that a is equal to 3. So now that we have that, we can have y is equal to 3 times x plus 7 times x minus 1. So that is our equation in factored form. Okay, so now let's look at the last scenario, scenario number 3. Here, for scenario number 3, we will need to identify at least 3 points and use those points to create equations by substituting them into the equation y is equal to ax squared plus bx plus c. So once we do that, in number 2, what we would do is we would enter the equations into the calculator by using the PolySimo 2 app on the TI-84. Okay, and it will solve that system of equations. So one thing that it tells us here is that we have an equation of the quadratic function, and it tells us that we have a vertex at negative 519, and it passes through the points 5 and negative 21. All right. So if we were to think about this, if I wanted to, I could make it a table. Okay. So if I make a table of these values, I'm going to place my vertex in the center because I know that around the vertex, I should have repeating y values. So I'm going to have negative 5 and 19 here in the middle because I know that's going to either be the highest or the lowest point. All right. And then I'm going to put the other point that they gave, I'm going to put that other point in, and I'm going to put the positive 5 here. And the reason why I'm writing it like this is because normally our x values are written in order, from least to greatest. So if I know that I need a third point, what you need to remember is that your axis of symmetry is the x value of the vertex. So that axis of symmetry is actually x is equal to negative 5. That's where my line is. And I know that each point has a point directly across from it. So if I think about the distance from the x value of negative 5 to a positive 5, that is a difference of 10 units. So I know that there is another point on the other side of that axis of symmetry, or the x value on the other side of that negative 5, that is going to be the same distance as that positive 5. So there's going to be 10 units. So I know that will have to be at a negative 15, and the y values will be the same at negative 21 because the y values should be equal. The only thing different should be the x values. So now that I have these 3 points, what I can do is I can make equations by using the standard form of a quadratic equation here to write my 3 points. So, and let me change the color here so that I can color code. So here I'm going to just change this here to this color. So here we can write our 3 equations. So I'm going to write the pink equation for the top point. So that is going to be negative 21 equals A times negative 15 squared plus B times negative 15 plus C. So that is that first equation here. All right. The next equation I'm going to write is going to be 19 is equal to A times negative 5 squared plus B times negative 5 plus C. And then the third equation is going to be negative 21 is equal to A times positive 5 squared plus B times positive 5 plus C. So now what I'm going to do is I am going to convert each of these equations and simplify them first so that I can put them into my calculator. So negative 15 squared is going to be 225. So I will have my top equation being negative 21 is equal to 225A minus 15B plus C. Okay, so now that is that equation. My next equation will be 19 is equal to 25A because negative 5 squared is a positive 25, and that is going to be minus 5B plus C. My third equation is going to be negative 21 is equal to 25A plus 5B plus C. So now that I have these, what I'm now going to do is I'm going to put these 3 equations into the PolySumO 2 app. All right, remember this is a system of equations, so we need the simultaneous equation solver. And then what we need to do is we need to tell it how many equations and how many unknowns that we have. So we have 3 equations and we have 3 unknown letters, A, B, and C. So once I do that, I'm going to press next. Now remember, depending on how your calculator is, you might see X, Y, and Z instead of A, B, and C. Or your graph may show up like mine. Either way, you should be fine. If your graph shows up like mine, you have to type in your coefficients and your constants. So remember, the A's are going to be put into this left column. The coefficients of the B's are going to be put into this second column. The coefficients of the C's are going to be put in the third column. And the last column will be our constants, or the numbers on the other side of the equal sign. So when I put them in for the pink equation, I'm going to have 225, negative 15, 1, and negative 21. For the green equation, I'm going to have 25, negative 5, 1, and 19. And for the brown equation, I will have 25, positive 5, positive 1, and negative 21. So now that I have that entered in, what I'm going to do is I'm going to press solve. And as you can see here, it tells me that the first value, which is the x1, that represents the A, x2 represents B, and x3 represents C. So I can write out my equation as y is equal to negative 2/5 x squared minus 4x plus 9. And remember, this is all because I put these 3 equations into the PolySimul 2 app. Make sure I write that down. And then I got that the values of A was negative 2/5, B was negative 4, and C was equal to 9. And this is how I was able to get my equation here. All right. So if you have any questions on writing equations from a quadratic, please let your teacher know, and have a great day.